Shouldn't have got that wrong. These ones are generally okay, right?
Yeah.
Okay, we don't need to go through them, right? No one feel the need? No. A couple of people did, however, get this inverse wrong. Not this one, actually. Shouldn't get that one, that's really simple. But the next one, I think, when we had to do the inverse function of x, I think I've said, like, make sure you've got the correct order of operations. And there was one with the squared as well, right? So when we do the inverse function of x, you've got to think, when we have f of x, what happens first? We cube it, and then we add 1, right? And you have to do the opposite. So we take x, we do the opposite in the opposite order. So it's -1, and then the whole thing is cube rooted, okay? You must do the order as well. You have to think about the order. Right. This is one. Now, I did put a hint. Do not need to expand the brackets to solve. That should have given you quite a big hint. So first of all, fg of x would be, take g of x, okay, stick that as x in this one. So it's that cubed plus 1. That equals 0. And this is where the hint comes in. So I didn't want you to expand those brackets. A couple of people did, and I was like, well, you did not read my hint. Even at the beginning of the test, it said read the hint. Okay, so now we subtract 1. We get x minus 2 equals -1. Sorry, not x minus 2, x minus 2 cubed. Then we take the cube roots. It's the kind of thing you were doing the inverse function, yeah? So x minus 2 is the cube root of -1, which, as you said, is still -1. Then you add 2, and you get x equals 1.
I did that so different, but I got 1.
Yeah. Well, to be honest, you could do trial and error, you could guess or whatever, but yeah.
I just tried 1 first.
Yeah.
No,
I mean, obviously,
I tried -1 first.
that method is not a very efficient way of solving things. If you're going to rely on just guessing the right number, this one it does work, but other ones it doesn't. And sometimes you miss out whether there's any other solutions as well. All right? So sometimes there'll be more than one solution. So we just need to think here: is there a second solution? Is there anything else that would work? Have we done anything in this which should have a second solution?
-1. Instead of -1, 1.
Well, this thing, if it was a square root, it would be.
But it's cubed, so it
But
goes
it's
back.
cubed, so it goes back. Plus, you can't do the square root of a negative number. Okay, but we're probably all right. But we should have that mental check. Okay, that was that. Okay, this was the one. A couple of people made that error. So g of x again. So what happens? X, then it's subtract 3, then it's square root. So the inverse is take x, square that, then add 3. Doing it in the wrong order. And again, you know how to do this. It's just in a test that you just try and rush it. You know, think carefully. It's not that you don't have the knowledge. Write down the range. Range means y values. So the range of f of x is what we know. So x squared plus 1 looks like that. This is why we did our work. Crossing at 1, so we know that y has to be greater than or equal to 1. And for the inverse function g of x, well, this is x squared plus 3. So we've got y must be greater than or equal to 3.
Was that like a 3-4 question?
Those ones are simple, they're the basic. These are the ones I would expect you to know how to do to a minimum. Minimum standard, those are the ones. Yeah? So yeah, I guess you could call them the 2, 3, 4 questions. Okay. What do you notice up here? 5. So write down the value of f of 1 as a hint, use the graph. So this was just checking whether you remember that a graph is an infinite number of points and represents the function. So f of 1, we go to 1, we go up, we read off 3. Okay, f of 1 equals 3. The inverse function of 2. Well, what happens when you do the inverse function? You can reflect it in the xy. Yeah, so you could do that first. You're going to have to. The other option is, remember we did it where you put the y value in and find the x. So in this case, we actually go to 2 on the y and look down for the x. So that's 0. That makes sense? So we kind of go the opposite direction. All right, nice and simple. State the domain of the inverse function. Well, again, if it's a swap, the domain of the inverse function is the same as the range of the original function. So the range of the original function was from -2 to 4. That's it. So we then go for the domain x goes from, come on, -2 to 4. Now the question is, this is where I could be a bit lenient, is it that or is it that? See, I would go for this because we have actually got the -4 and 5. Okay, so that means that value at the end, although we don't have a filled circle or an open circle, we are told that it's equal to -4, 5. So we should have the and equal to. Right. Sketch the graph. Well, as you said, that's relatively simple. So we would just, if you want, put in a sketch, little line using your ruler of y equals x, and then just start plotting the points, making sure you know where they go. So be accurate. Right, so then your inverse function. Okay. Something like that. Right. Be very accurate, very easy. Yeah. So again, you know it, don't you? You know it's a reflection in y equals x. Okay. This one. Now, Ethan, I have to take you up to task on this one. Okay. In fact, not this one, the second one. You came up and said, is that one in the next one? I know I've redone the paper now. I said to you, no, I put lines on your paper, I said separate, double, and you still used 5 to answer 6. Still did it. What is going on? This is a part of another bigger question. You couldn't do the rest of it, but I mean, this bit should be absolutely no problem for you, in that you write e to the x minus 2, then that goes in for x. So it should be, switched off. 3x plus k. Now I'm happy enough if you leave it like that, to be honest. That does it. But if we expand, we get 3e to the x minus 6 plus k. A couple I missed, so if it's right, tick it. Yeah, I kind of, because it was crushed in, I did miss on a couple. Thought I'd gone back. But, for instance, here's the problem. If you did this, it's fine. If you did that incorrectly, you're showing again you don't know how to expand brackets. At least one person put -2 there still. Plus
yeah, that was. I forgot to put it.
Yeah, but that's a fundamental issue. That's a real issue that we need to sort out there. Okay, separate question. I know I didn't make it so clear when I created the paper, but I did tell you in the test, and most of you were all right. Different question. This function is not the other function. All right. Same idea as before, though. What is f of 1? Well, f of 1 is 2. Inverse minus 2 means go to minus 2 on the y and read across to minus 1. Okay. F of 1. Now this is probably would get, although it's very easy, I've not actually necessarily done these kind of things with you. So this could, even though it is easy, be considered a 7 or 8 part question. But you're going to go, well, that's easy. But, because it's unfamiliar. So it's f of 1. And we've got to use our graph. So we find, actually, that f of 1 is 2. So then we do f of 2. And we get 6. Yeah? That's the answer. Easy enough? Yeah. Sketch the graph. Well, some of you are just expecting to see the inverse function, didn't read it properly. So when you have f of minus x, what kind of transformation is that? Reflecting the y-axis, or the x coordinates become negative. Okay, so again, we mark our points. Okay, and we reflect across the y-axis. Did I? Shouldn't have done. Tip that. Okay, sorry. On the y. Okay, reflect across the y-axis. All right. Any questions on that? So a few people have just reflected in the wrong place, not thinking carefully enough. You know. All right. This one looks quite brutal, but actually it's quite easy. Some of you made the common mistake. The wording is where it gets difficult, but actually the question is easy. So f and g are functions such that g of x is found by transforming f of x in this way. That's what it says. Okay? It even tells you that it is a vertical stretch by a factor k, which is 3. K equals 3. Then a translation AB. So I kind of thought, well, we haven't done the vectors for transformations. I kind of expect you have done it in the past. But I added, that's the x and y direction. Okay. So it has been A translated in the x direction, how far? 2, in which direction? The right, so positive. Therefore this is positive 2, not negative 2. Yeah, a lot of people put the negative 2. All right. And then plus 1, or B, is where it goes in the y direction. So it's just plus 1. All right. So if you don't know, a translation, you don't say units up, units left, units right anymore. A translation is described by a vector. So I would be saying it's translated through 2, 1. So you know it's been moved 2 in the x direction, in a positive x direction, and moved 1 in the y, positive 1. Okay? If they're negatives, they go in the other direction. Okay, this one, again, seems harder than it really is. I even changed that word. I thought, no, you know the word map, but all right, I'll give you transformed. So h of x, then we've just got this number here. All right, so what does that do when you multiply outside? Which coordinate does it change? The y, and it multiplies it by negative 2. So which one's the y coordinate? So it becomes 3 minus 8, no? Yeah, well that's where we need to learn, isn't it? That's where an easy question catch you out, because although you know you have the knowledge, you look at that words and you don't take out what you know from it. This one, however, I would expect everyone to have got this, because we literally did it loads. Log to base 3 of x plus 2. So what we know is we base it all on a log to the base 3 curve, and it's been shifted left 2. Alright? So it's not been moved up or down or anything. So normally, what would log to base 3 look like? It would look like this, wouldn't it? Yeah? Where would it normally cross? No, 1. It's been shifted 2 in the negative direction, so it now crosses at -1. So the x-intercept is at -1, 0. Why would I give you it for -2? That's just wrong.
I was basing it off of this graph. I forgot to like transform this graph. So I just
Yeah.
I did like the points. I don't know about.
And then it says find the equation of the vertical asymptote. So the vertical asymptote is here. It was the y-axis. So where is it now?
No,
It was at 0, it's moved to -2. Alright, what's the equation of a vertical line? X equals -2.
I put greater than. I put f of x equals log.
So it should be x equals -2. Alright, I did see someone say y equals, unfortunately that's a completely different line. It might be someone's not here. Okay? Yes?
So what's the y-intercept?
Yeah, I told you to cross it out with that.
Oh, okay.
Where's Ashley?
Play music.
I must not.
Michelle, SDLC.
Yeah.
SDLC now, yes. She was off musicking yesterday. That's right. Leadership Diversity Conference. Right, so don't forget you're recording. The next one then. So that logarithmic one, I hope you are looking at that going, that easy, should have got that one. This one, again, I've put hints, take careful note of the function. The reason why I've done that, and I even said it in class, there is no plus k on the end, and there's no plus c, whatever. Therefore, we know it's not been shifted up at all. So this is actually one of the easiest of the ones we talked about in the previous lesson. And yes, it's a stretch, isn't it? Where does it normally cross? A function that's just p cubed power x normally crosses at 1. So obviously that has been stretched by a factor of 8. So then we know it's 8 times something to the power of x. What's the something? Well, to go to the 1, that will have been multiplied by 8. So down here it should have been 1, 2. So that's the 8 times 2 to the power of x. Okay? So if you write that, that's fine, but hopefully we'd have p is 8, q equals 2. Alright. Then we've got to find k. So this is testing your transferable skills. So, so we've got y equals 8 times 2 to the power of x. We know it's 1.5k, which means that's x and that's y in the coordinates. So we go k equals 8 times 2 to the power of 1.5. Now again, I added a hint and give your answer to k as a surd, meaning square roots, radicals, yeah? So that would make you think it's going to be 8 times 2 to the power of, well, I would change that to 3 over 2, which is then 8 to the power of the square root of 2 cubed. So that's 8 times the square root of 8, which is a step, but we can then simplify that to 4 times 2, which gives me 8 times 2 times root 2, which is 16 root 2. So that's k. Okay? But again, do you see, like, if you're going to take a positive from it, none of you are looking at that going, I have no idea what you just did there. Right? You've all seen that. You've all done an assessment on that before. You all know how to do it. What the problem is, when it comes to a test, applying your knowledge. You know? You have this knowledge, it's just about applying it. Right? Is that the last question? Another one. Okay. 2 more. Alright. So these ones, especially the one I put a star in, this is a very typical high-end question that's easy but tests a real deep level of understanding, even though it's a really easy question. And you're going to go to me, oh right, yeah, fair enough. So f to the minus 1 of 3, well, there's 2 ways to do that. We either find f to the minus 1 of x first, which some people did, which is x squared minus 7, and we just do put 3 in. So that's 9 minus 7 is 2, right? This is where part B comes in though. Part A could also have been done by doing x plus 7 equals 3. Remember doing that? So if you substitute into the inverse, that's the same as solving for the initial function. What happens? We square it, we get x plus 7 equals 9, we subtract 7, we get x equals 2. Same idea. Okay? This side, that's the most useful one in this question. That's the kind of knowledge you have to have. Part A can be solved either way. There's no prejudice on which way you do it, but part B, if you can't think in this way, part B is almost impossible. So what we do is this. Let g be a function such that g minus exists for all real numbers. That's just saying x can be anything you like. It's got no limitations. Just has to say that. You don't have to take too much notice of it. Given that g of 9 equals 4, find the inverse, so f of the inverse g of 4. Well, initially there's a problem because you don't know what the inverse of g, the function, is. So you can't put it into 4 to then put it into f. Make sense? So, but we do actually know it. So let me make this is the real white starred. G to the minus 1 of 4, that's the first thing we've got to do here, you happy with that? Is the same thing as doing g of x equals 4. And you're told that g of 9 equals 4. Alright? So if g of 9 equals 4, we can then go back and say, well, the inverse of g of 4 equals 9. Okay? Therefore, to follow this through, we then do f of 9. Okay? And f of 9 I can work out. Right? So that would be 9, what is it? Plus 7 square root. So that's the square root of 16, which is plus and minus 4. Okay? This one's a tough question. It was a tough one.
I knew you would have something like that.
We have discussed this, but this tests how much you're paying attention and how much note taking you're making, because I kind of get the impression that sometimes, although you're you're very good at having lots of discussions and talking about lots of things and being very interested. Sometimes you don't focus on the little things that make the difference. And I think this was one of those questions. All right. The y-intercept is when x equals 0. Okay, so we do 3 times 0 minus 6 divided by 0 plus 1, and we end up with negative 6 over 1, so is negative 6. So the coordinates would be 0, negative 6. Okay, the x-intercept when y is 0. So we've then got 3x minus 6 over x plus 1 should equal 0. Now, this is an interesting one. It checks your knowledge. That's a fraction, right? There's only one way a fraction can equal 0. So we know that 3x minus 6 equals 0, which means 3x is 6, which means x is 2. So that's 2, 0 is the coordinates. Yes.
I did it like a different way.
Yeah.
It wasn't as like time smart, but I just did like a table, like when like x equals 0 and then graphed it. It's just like easy,
Yeah, that's the way to do it. Like you say, time smart is a very good way of putting it. It's, you know, if I would give you as much time as you like and solve it however you want, fine. You know, it shows you've at least come up with a bit of initiative to solve the problem. So that's great. It's fine. It's better than leaving it and not attempting it, isn't it? So just like you say, when you've got the time pressure. Okay, the vertical asymptote, quite simple then. The vertical asymptote is an x equals, because it's vertical, what can't x equal? Negative 1, why? Yeah. That's the answer. Yeah. Right? You would not believe the number of times that I've had to point that out to people. They tell you the answer is in there. Why is x not able to equal minus 1? Yeah, if I put x as minus 1 into the denominator, I get 0 on the bottom of a fraction, and it can't have that. Okay? But it tells you the answer to that one. The horizontal asymptote is a bit different. The horizontal asymptote is y equals 3. You got 3. How did you get 3?
Well, because I had the graph,
Yeah.
I just knew that as I went from main points, it just like gradually like started to curve.
Yeah. But that's basically it, isn't it? Right? I would say that's a very good way to do it, but I've got a method which is, we don't actually need to graph it, but let me show you. So we've got 3x minus 6 divided by x plus 1. So we're looking for an asymptote. So what I'm going to say is that that function gets really close to the asymptote when the x values get either really big or really small, right? Yeah? It goes on forever. And it gets really close to the asymptote, so close that you can't tell the difference when x is really big. So what if I were to put, well, let's try x as 1,000,000. I would end up with 3,000,000 minus 6 over 1,000,000 plus 1. So when I put those numbers in, you can then see that actually the minus 6 and plus 1 are kind of insignificant. Yeah, they're so small compared to 3,000,000 and 1,000,000, yeah? They're kind of insignificant, but they're significant in one very important way. They will stop it ever being 3 divided by 1. Exactly. Will never exactly ever reach something, it's going to be very close, isn't it? If you did 3 million minus 6 divided by 1 million plus 1, you would get very, very close to 3. But the plus 6, or the minus 6 and the plus 1, make it just that fraction different. It will never ever be 3 over 1. And you can actually see it when it's 3 and there's a 1, and you can see that that's where it's going to be, so the y asymptote. So that's a tough one. We didn't talk that through really. Alright, I think I did it briefly. I did mention it in the lesson briefly, but that's why it was starred and why it's the last question. Okay? Yeah. Any further questions on any of that?